Hi, in this video we're going to find the minimum point of a quadratic graph where we have to complete the square ourselves. And we previously saw if we have this completed square form, which remember is where you have x plus or minus something all square, then plus or minus something after it. So the x is in a bracket that's squared like that. Then the turning point we could find by just negating the value after x. So the plus b after the x becomes minus b, and that's the x value of a turning point. And then the thing after the square, the plus c, is just the y value of a turning point. And what I mean by a turning point is, if I just draw it, if the graph was to say looks like something like this, then the turning point is basically where the graph is at its minimum, or it could be if it was upside down, it's where the graph is at its maximum. But basically a turning point means where the gradient of the graph, the steepness, is 0. Because you can see at this point here, the minimum point, the graph is momentarily flat. So we call that a stationary point if the gradient is 0. And a stationary point might be a minimum or a maximum. This is a minimum point because the y value is at its minimum here. Now, what we need to do, therefore, is to complete the square for this expression here. Let's do that. If I've got x squared minus 8x plus 17, how do you complete the square? Well, what you do is you take the value in front of the x, the coefficient of the x, in this case minus 8, and you halve it. And then you open a bracket, you put x, then half that value. So we halve this. So that becomes minus 4. Half of minus 8 is minus 4. It's that squared. And then what you do is whatever that value is, you square it and throw it away. So you square and throw away. So minus 4 squared is positive 16, and then you throw away the 16. So there's always going to be a minus after this, minus 16. And then finally this plus 17 here, you just copy down here. And then we can simplify that. So sorry, this is a bit squidged, but let's just do it on the side. We have y equals x minus 4 squared. And then minus 16 plus 17 is just plus 1. Now, as we said, whatever this value is after the x, we just negate that to find the x value of our turning point. So minus 4 becomes plus 4. Negative becomes positive, positive becomes negative. And then whatever this value is here, after the squared, that just becomes our y value. So we just get 1. So therefore, this turning point here is 4, 1, that red point there. And that is the turning point, the minimum point that we want. So the minimum point of our graph is 4, 1. And that's the final answer. Let's do another one. Again, we're going to complete the square. So y equals x squared plus 6x plus 11. We're going to halve the number in front of the x, so halve the coefficient of x, as we call it. So it's going to become x, and then half of it is plus 3. So we have x, then that number, half the number, close the bracket, squared. Remember, we square this and throw it away. So the 3 squared is 9. We throw it away. And then we've got that plus 1 still at the end. And then if we just simplify it, x plus 3 squared. What's minus 9 plus 1? Well, it's minus 8. So there we go. That's the completed square form. And then as we said, we negate this value as the x value of our minimum point. So it's minus 3. And then we just use this value after the squared in its original form, minus 8 like that. And that is our completed turning point. So let's just fill it in. We've got minus 3 minus 8 is the final answer.